สมัยก่อนไม่ร้อนแบบนี้หรือเปล่าไม่รู้เหมือนกัน สมัยก่อนห้องจะต้องมีหน้าต่างสมัยนี้ห้องไม่มีหน้าต่างด้วย
global warming
นะครับก็อบซาวน่าไปนะครับผม Okay, we continue with the segmentation. The first approach of segmentation was what? Age-based, right? Age-based or discontinuity-based. Basically, we were looking for discontinuity which will separate the subject, okay, the image into two parts. Okay. This is the second half of segmentation, which is region-based. Okay, region-based has to do with the finding the similar regions. Okay, a region with similar property will be grouped together. Okay, the first and simplest method of segmentation is thresholding. Okay, there are many kinds of thresholding. Okay, it could be bi-level thresholding. That means it has only one threshold. One threshold can separate the image into two parts, right? So bi-level into two levels. Okay. Basically, we look at the histogram of the image. The histogram, remember, what was it? It represents the pixels on the horizontal axis is the gray levels, right? And the vertical axis is the number of pixels with such gray levels. So when you use the bi-level thresholding, you have one threshold T. We look at the histogram. If the histogram looks like two mountains like this, then the threshold is somewhere in between these two mountains. Or it could be multi-level thresholding. Multi-level thresholding, if the histogram looks like this, there are three mountains like that, then you need two thresholds to separate into two parts. Okay. Thresholding can also be done globally and locally. Okay. Globally means we done the threshold on the whole image. Okay. And well, unfortunately, the image was misaligned. Okay. Basically, we got to find globally means you apply the threshold on the one image. Okay. Local means you got to do thresholding on sub-image. Okay. So you separate the image into sub-image and then you do locally. Okay. So you might have different thresholds for different sub-image. Okay. Static or dynamic. Static means the threshold is fixed. Okay. Dynamic means the threshold is not fixed depending on the image. Okay. Some image there is an algorithm. Okay, depending on the image. Okay. For example, here this is one of the things we apply global thresholding. Okay, how would you estimate the global thresholding? In this image, you can see that it has the histogram itself looks like it can be separated into two parts. Okay, the easiest threshold could be the one in the middle. Okay, could be the one you know. Suppose you got the 256 grade levels. Threshold would be half of the 256. Okay. However, if these mountains may not be, the threshold may not be exactly half, we can do adaptive thresholding. Okay, and this is the way we do adaptive thresholding. For each image, okay, first we might want to estimate the first threshold, and then we're going to change this threshold according to the image. By the first threshold, okay, can separate the image into two groups, G1 and G2. And then you find the mean of G1, okay, the mean of the intensity values in group 1, and the mean of G2, okay, intensity in group 2. Then we're going to find M1 and M2. And then we set a new threshold. We set a new threshold as T equal to M1 plus M2 divided by 2. So halfway between the group 1 and group 2. Okay. And then we repeat it. Okay. And once you get a new T, you go back and see this T separate the pixels into two groups, group 1 and group 2. Okay, and then you find the mean of each group, and then you have a new threshold m1 plus m2 divided by 2 again. Okay, you do it iteratively until the t does not change, okay, or change very small, okay. And that's how we get the adaptive thresholding, okay. In MATLAB, they actually use this one called, the MATLAB function is called gray thresh, Greythresh, okay, gray thresh. You don't need to specify the threshold. You just throw in an image, the MATLAB will determine the threshold for you, okay. You can try it on several images. Threshold can be done, okay, if the image looks like this, okay. This one you can see the image looks pretty, the histogram looks very nice, okay, with two mountains. The background and the objects, okay, the background is the first peak here and the object is second peak here. And you can see if this one, if you have uniform illumination like this, thresholding works well. However, if this image has ununiform, uneven illumination like this, okay, and you have the background, the object on this background, you can see that it will screw up the threshold, okay. The threshold, the histogram going to move this way, to most of them are black. And if you're going to be using the gray thresh, okay, or the automatic threshold, okay, you might choose this line as a threshold because it separates the two mountains. It may not work well, okay. This is the result after you use automatic thresholds, okay. In this case, in the case where there is background is not even, okay, non-uniform background, you might want to do thresholding in the sub-image instead of the global threshold, okay. We do local thresholding instead, okay. For example, here for this image, we can do the thresholding. We do dividing the image into sub-blocks like this, sub-images. And for each block, you apply the threshold, okay. Each threshold in each block probably not the same. However, after you've done that, this is what you get. You get a better result. However, there's some problem though. The problem is with these two, this block and this block, you can see, still give you the bad decision. Okay, why is that? Let's take a look. Let's take a look at these two blocks here. The block above looks fine. Okay, it can get good threshold. The block below, how come it got an error? Okay, the error came from here. The block above, you can see that if you look at the histogram, it can be separated into two parts easily. Okay. This mountain, so the threshold is in between, so it works. But for this block, you can see most of the parts are white, okay, are object, which is this mountain, this big mountain. And there's a little thing here as a background. The amount of background here is too small. See? The amount of background here is too small. So when you apply the thresholding, instead of doing the threshold right here, okay, you do the threshold in between, in between this object, okay, the automatic threshold. So it won't work, okay. You want to do, so you might want to subdivide the image again, okay, until the amount it becomes, the amount of background and the object are almost the same, like this. And that's how you can get the good threshold. Okay. So this is one way to do segmentation, okay, locally, okay, local threshold. Another image, okay, so choosing the threshold is the most important part, okay. So here is some optimal thresholding method, okay. To estimate the threshold, that we want to estimate the threshold T that minimize the segmentation error. What is the segmentation error? Suppose we got the two histogram. In this case, we can assume Gaussian. Okay. Suppose you got two histograms that overlapping like this. We want to set a threshold T such that it minimizes the error. What does it mean by the error? The error is this. Okay, there are two different kinds of error. This is error number one. Error number one is the red parts. That means you integrating P2. P2 may be the object. Okay. But the tail of P2, that's underneath, that's below the threshold. This one is supposed to be the object, but it's identified as the background. Okay, the red one is the object that is identified as the background. Okay, and the blue area is the area of P1. Okay, area under curve P1. However, it is identified as P2. Okay, suppose P1 is the background, P2 is the object. So part of the background is identified as the object. Okay, so we want to find the threshold T that minimize these two errors, the sum of these two errors. How do we do that? Well, we take the derivative in respect to T and set it to 0 and solve for T. Okay. But in this case, you need to know, this case, we assume that P1 and P2, if you use that, okay, this method is called calculus of variation, okay? And to prove that, this is what we get. We got P1 times probability of P1 at T equal to P2 probability of P2 at T. This is the value of T that makes these two equal. It will minimize the error. However, if we assume both P1 and P2 to be Gaussians, okay, if we assume both P1 and P2 to be Gaussian, or for this method, you got to do iteration, okay, you got to do iteration just like what we did earlier, okay. However, if both of them are Gaussian, this is what we have. We have threshold as mu1 plus mu2 over 2, and then plus sigma square over mu1 minus mu2, times ln of P2 minus over P1. Okay, this is the equation for the adaptive optimal thresholding. You can see this, that you can see that this formula is similar to the one that we just did in the global thresholding here, right? Because we set T to be M1 plus M2 over 2. How is the difference? This one means here, this is the analytic formula. Okay, you can see if the probability of P1 and P2 are equal, that means the chance that it's going to be the background is the same, about the same as the chance it's going to be the object. Okay, so if the object is about half of the area of the background, then what happened to this term? P2 over P1 would be equal to 1, and ln of 1 is 0. So this whole term disappears, okay? And you end up with mu1 plus mu2 over 2, which is exactly what we just did for the automatic thresholding here, okay? Automatic as thresholding here, okay? So that means you got to assume that the object is about the same size as the background. It's only half of the background of the whole image. Okay, and that's it for the optimal thresholding. Okay, here's the example of doing optimal thresholding. Okay, they have this image, and we obtain the histogram. Okay, and you do optimal thresholding, and you can separate the object. Okay. Local thresholding, if the histogram peaks are tall and narrow and symmetric, we can separate the threshold by the deep end. You set the threshold at the deep alley. okay, and it's easy to detect. However, pixels that near the edge between objects and the background, okay, may result in such histogram. However, we can combine gradient and Laplacians, okay, to perform local treachery as well. Okay. Here is the way we can do. Okay, we do gradient. Okay, we can separate into 3 parts. Okay, we got thresholding into gradients here. Okay, this one they do 0, 1, plus and minus, 0, 1 and negative 1. Okay, 0 plus 1 minus 1 and negative 1. Here we can say that if the gradient is less than a certain threshold, it's equal to 0. That means you're looking for when the gradient is small. Okay, if the gradient is large, then you do the Laplacians. Okay, for the large gradient, that means there is a lot of change. If you got Laplacian is also large, that means it's increasing. The gradient is increasing, right? Then you set up as a positive. And this one, if the gradient is less than, is negative, and the gradient is large, and the Laplacian is small, then it comes negative. So you can use it to separate the objects into, well, this one, this thing is not good, okay? This is used to segment the signature, okay? Multi-spectral thresholding means usually we obtain it using in color image, okay? Multi-spectral in this case means you do thresholding in 3 different channels, okay? 3 different spectrum, red, green, and blue, okay? And for a particular red, threshold for red, threshold for green, and threshold for blue, you can segment the area with certain colors. For example, here, actually this one on the left is supposed to be RGB, okay, RGB image. So if you set a certain threshold for red, green, and blue, you can segment the face, which is supposed to be the face color, okay? Or you can set the threshold to be near the scarf color, okay? That's how you threshold the object. So this is you threshold the object based on color, okay? Based on color. Go ahead and do this one. In read rise.png, we use gray thresh, okay? Gray thresh is the automatic thresholding that we use in MATLAB, okay? Yes. Segment the rise from the background. Go ahead. เดี๋ยวต้องไปหาช่างให้มาดูหน่อยนะถ้ามาอยู่ดีเมื่อกี้เปิดแอร์ก็เปิดได้แล้วอยู่ดีก็ดับไปเกิดอะไรขึ้นดับแบบดับไปเลยเริ่มร้อนแล้วเนี่ยเมื่อกี้ลงไปชั้นล่างก็ไม่มีใช่ไหมไม่เคย เคได้ไหมได้เมล็ดข้าวไหมนับเมล็ดข้าวดอกไหมแต่ threshold มันไม่ค่อยสวยเนาะนะครับเม็ดล่างๆจะไม่ค่อยดีใช่ไหมเพราะว่าเม็ดล่างๆมันทำไมเม็ดล่างๆมันยูนิฟอร์มมันไม่ค่อยยูนิฟอร์มนะครับก็นับได้อยู่แต่เม็ดล่างๆอาจจะไม่ค่อยดีจะเห็นว่าฮิสโตแกรมเนี่ยมันก็ไม่ได้แบ่งเป็นภูเขาได้ชัดเจนเท่าไหร่นะครับถ้าแบ่งภูเขาได้ชัดเจนเนี่ยก็จะยิ่งดีนะครับโอเค next is region based the thresholding is actually for me I consider it's region based segmentation. Okay, but some paper call histogram based. Okay, basically it use intensity as the similar criteria. Okay, most of the region based. Okay, basically this is what they do. They partition image into groups of similar region. The word similar in this case is you got to define by yourself. Okay, what are to be similar? Okay. It could be intensity, it could be anything else, okay? The entire image got to separate into n sub-regions, okay? R1 until Rn, okay? And the union of them all has to be the whole image, okay? So in this case, when you do sub-image here, there will be no overlapping. That means the region that are disjoint Ri intersect Rj got to be empty. Okay, so there is no overlapping regions. Okay, all pixels in Ri has to have the same criteria. Okay, and all different Ri and Rj, if they are union, it got to be false. So different region got to have different criteria. This is the definition of region-based segmentation. The two techniques that we often use are the region going and region split and merging. Split and merge. Okay. Region going is the one that's popularly used at one time. Okay. First, they start with a seed point. Okay, with a seed point within the image. You can start with a seed point within the image, and then the region start growing from the seed. So basically you look around the seed and see if the pixel around it the same criteria as the seed. If they are, then you include it as the object. Okay. If they are not, then you exclude that and then you move on until you investigate all the pixels within the image. Okay, this is called region going. However, there is a challenge on region going. We found out that sometimes if you set up the same image, if you set up different seed, okay, seed one seed over here and one seed over there, they may not end up with the same result. Okay, so it's sensitive to the seed. In that case, it's not good, right? You need to know a way to do such that is invariance to the seed. So you got to have a way to do. Okay. The criteria that you use, we're gonna learn. Okay. For example, you could use the mean, the variance, the anything as a criteria. Okay. Could be we use it. We're gonna use those criteria that we learned from the next chapter, which is called descriptors. Okay. The thing about region going is that. Another challenge about region going is connectedness. Okay, the region going usually it has to be connected pixels. Okay, another challenge is the stopping rules. Okay, when to stop? Well, if you want to search from the seed and search is throughout the whole image, okay, it can be very time consuming. Okay, a lot of times you want to stop earlier than that. as the criteria. For example, here, region going, we start with this image. We start, how do we select the seed? In this problem, they select the seeds from thresholding. They do thresholding first, and then they select these pixels as the seed. And then they continue with the region going. Okay, so we go from this seed to get this area. And you can see all these are connected as one component. Okay, and from this seed, okay, it may grow a little bit further, okay, as one component. In this case, you can judge, okay, how many leakage points are there, okay, how many leaks holes are there, okay, after region growing. Okay. It's better than the simple thresholding. Okay, it has been proven that region growing is better than the thresholding. When the thresholds is hard to find, for example, like this. Okay, if you do thresholding, you can see that the image, some different region may not be connected. Okay, different region may be not connected. But if with region growing, you are sure that they are connected. The second method of region based is merging and splitting. Okay. The procedure is like this. First you have the image, you split first, okay, you split the image. Okay, for example, and what's the criteria to split? Okay, criteria to split is like this. Maybe you use the variance. If the variance is too high, you want to split. Okay. For example, so that if the first image is split into 4 parts, R1, R2, R3, R4. Okay. So the region R is split into 4 parts because they have different, very high variance. That means they could contain more objects and the background. And for each of these regions, you split again. You check R1, R2, R3, R4. If they have high variance again, you split again. Okay? For example, here, R1 and R2, R1 probably has low variance now. R2, low variance now, you don't split. R3, low variance now, you don't split. R4, it still have high variance, you split. Okay? So you do these until there is no more splitting. And then you continue with R1, R41, R42, R43, R44. Which one would be split? Okay. Which one would stop splitting? Okay. And then you continue so on, okay, until you got the decision tree like this. The next step is to merge. Okay. Merge means you check regions that are next to each other. Okay. For example, here R41. R41 is next to R2 and is next to R3. Then you need to check some criteria that they are the same. Okay, for example, the intensity values. If R41 has the average intensity value as R2 and R3, then you merge them as one region. Okay, R42, you connect with R2. Okay, you may merge with R2 or not. Okay, R43 may be merged with R3 and so on. And R44 could be merged to the one on the right and so on. Okay, so after you split, you want to merge the signals. Okay, that's why you call split and merge. Okay, this is the image. The result image is throughout. Last but not the least is the watershed method. The watershed method for me is called the hybrid approach. Okay, it uses both region age-based and region-based. Why is that? Okay, let's take a look. Watershed method is one of the popularly used method for segmentation. First, they consider the image as a 3D surface. Okay, consider it as a 3D surface. So we imagine you got a 3D surface. Okay, First, you got to find the local minima, okay? Local minima. And use that local minima similar to the C, okay, of the region growing, okay? But instead of growing around it, okay, region growing around it, we call it flood the image. We flood the image around it, around it, around it. Basically, the water level will getting larger, higher and higher. And whenever part of two body of water, okay, the local, one of the local minima and the next local minima, if they start to merge, we form a watershed, form a barrier between them, okay? And that's how we build a dam to divide them. That's why we call it the watershed line, okay? This is the algorithm. You start with the edge image, okay, and find the local minima. The local minima will start to rise the level, the water level. Over here, the water level is getting higher and higher, higher and higher, higher and higher. At this point, you can see here, and it goes this way, go this way. At this point, you can see this body of water on the left, this body of water, and this body of water start to merge if the water is high, okay? Whenever it start to merge, you build a line, okay, a dam. This is a line here, okay? And you continue furthermore, and then you see this body of water and this body of water, these two body of water is about to merge. So you build a dam to block them. You can continue this until the end. And that's how you get the region. Okay. This is the algorithm. Okay. They have been used algorithm in MATLAB. Okay. In computer. So this is the result. Okay. This is the original image on the left, top left corner is the original image. First, you do the edge detection, detecting the edge. Okay, if you detect the edge, you're just going to get. And then you find the local minimum, okay, which is here, 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 here. Okay, local minimum. And then you build the water, dam, build the dam, rise the water, and then build the dam. Okay, and that's how you segment the image. Okay. Go ahead and do this. There is MATLAB, but this one says it won't work yet. How come? Watershed. Somehow it's not working. In filter มี Sobel mass ถ้า watershed ก็ตัวนี้พอทำไมถึงไม่เวิร์กอะไรนะอาจารย์เอาทำไมไม่ตัดแต่งครับมาจาก MATLAB นี่แหละใช่ไหมร้อนแล้วเนาะเวิร์กไหมรูปเนี้ยมันเป็น3 รูปนะเป็นเหรียญแล้วก็เหรียญแล้วก็มืดเลยเหรอทำไมถึงมืดอ่ะwatershed ไม่เวิร์กอ่ะเวิร์กเพราะมันมืดสนิทเลยมืดสนิทเลยมันทำผิดอ่ะสิทำไมถึงผิดวะจะพูดกันไหมมันจะต้องแก้ออกมาได้แต่คำถามคือทำไมมันแก้ไม่ได้มันต้องลืมสีอะไรสักอย่างตัวwatershed J เป็นตัวอะไร เป็น you in เนาะต้องแก้มาให้ถูกเราใช้ Sobel replicate ทำไมถึงเราใช้ replicate ต้องไปดูในแมทเห็นไหมได้ไหมความจริงมันในแลบแมทแลบมันมีมันนั่นอยู่แล้วนะwatershed A is the image, right? Watershed transform find the catch basin or watershed ridge line into the image by treating it as a surface.รู้สึกว่าตัว watershed เรามันจะไม่ถูกต้องไม่เป็นไรนะครับ Okay, we found out that most of the time watershed there's a problem with watershed method. It's called over segmentation. Okay, most of the watershed, if you not control the local minimum, sometimes you get so many local minimums. Okay, if you got too many local minimums, every time the watershed flooding, the water flooded, it will form the boundary, okay, from the dam. So it can result in over segmentation. The way to go around it is to limit the number of markers as limit the markers, okay. Marker means the starting point or the seed, okay. You limit the number of markers, okay, as the watershed to start, okay. In that case, the watershed will have only the number of seed that you plant onto, okay, and that's the answer for the watershed. Last but not the least is the motion segmentation. Motion segmentation usually done in video frame. Okay, video processing, so image frame from videos. So we can have the difference between the two. F of xy t1 minus f of xy t2. If it's more than a certain threshold, that means something is moving within the frame, within the image frame. Okay. and with that we can segment it from the motion of the image. Okay, there are two different things: the absolute ADI, okay, accumulative difference image, or it could be positive ADI or negative ADI. For example, here, this one would be the one in the middle is the positive ADI. This one is a negative ADI. That tells us the direction of motions. Okay, this one is motion moving this way. This one motion moving this way or something. Okay. However, you can have absolute. That means there's some motion. It doesn't matter if it's going this way or that way. At least it has some motion. Okay, and you got the image segment from that. Okay. This is the image they use to segment this object, okay, that is moving across the road. Okay. And that's it. Wow. เร็วมากเลยที่เหลือไม่มีอะไรแล้วทำ segmentation นะครับ There are many kinds of segmentation that has been done, okay? So I suggest you find some papers and present it to your friends, okay? วันนี้ร้อนมากๆโชคดีว่าเลคเชอร์มีน้อยเนาะ เดี๋ยวคราวหน้าถ้าเกิดไม่ได้ปิดเขาไม่ฟิกแอร์นี่ทำไงวะเนี่ย
มีใครใช้ห้องนี้สอนอีกไหมจ๊ะมีวิชา
เดี๋ยวมันต้องมี
ฮิวริสติกวิชา
มีอยู่แล้วมีวันศุกร์
มีฮิวริสติก
ใช่ทำไมอยู่ดีมันดับไปเดี๋ยวต้องมีคนมาแก้อยู่แล้วล่ะแต่บังเอิญไม่ใช่วันนี้เดี๋ยวตรงนี้ให้ส่งการบ้านนะครับยังไม่ได้ให้ส่งใช่ไหมได้เปเปอร์มายังเอ่ยยังอีกเหรออุตส่าห์ให้เวลาทำเปเปอร์
กี่อันครับ
อันเดียวพอเปเปอร์อันเดียวที่เราจะทำนะครับ Digital Image Processing 514งั้นก็ต้องให้ submit ใช่ไหมถ้าไม่ submit ก็จะไม่ทำกันใช่ไหมโอเค
homework 7ใช่ไหมจ๊ะ
homework 7 segmentation เดี๋ยวเราต้องมี homework segmentation
homework 7ไม่ได้ส่งเปเปอร์นะ
เราอันนี้ paper นี่ homework อะไรแล้ว homework 7 นะครับ out date today due date next week okay. Submit a file นะครับให้ทำอะไรเอ่ยเลือก choose one paper on image processing นะครับ from IEEE ด้วยนะ
IEEE ด้วยเอารีสเกตได้
explore ที่อื่นมันก็ส่วนใหญ่ก็ IEEE แหละใช่ไหม
วันนี้ผมเปิดไม่ได้จะแบบต้องสมัครสมาชิกเลย
ไม่อยู่ใช้จุฬาเปิดได้ล็อกอินจุฬาเปิดได้
ผมยังไม่เคยใช้
ผมใช้ของ Sign Direct มา
Sign Direct ก็ได้มันก็จะเป็น IEEE เหมือนกันแหละใช่ไหม Sign Direct ก็ได้ไม่เอา from ก็ได้ต้องควรจะมาจากเปเปอร์ที่มีชื่อเสียงนิดนึงเข้าใจไหมนะครับผมนะครับ on image processing that you want to do as project โอเค submit นะครับ submit อะไรบ้างแต่เนี้ยปัญหาของเปเปอร์ส่วนใหญ่เนี่ยคือ you จะไม่ค่อยมีภาพนะนอกจากว่าคือในเปเปอร์มันจะมีภาพมี database ภาพให้นะครับถ้าไม่มีภาพเราต้องทำภาพเองเพราะฉะนั้นอันนี้ต้องใช้ความสามารถนิดหนึ่งนะครับผม submit นะครับ the original paper นะครับ2นะครับ summarize นะครับให้ write คล้ายๆกับทำ senior project นะ write the summary of what write okay your objective นะครับ introduction objective นะครับแล้วก็ plan of action นะครับ
นะครับก็คืออ่านเปเปอร์นี้ให้เข้าใจนะครับอาจจะเป็น 1 to 2 paper ก็ได้นะ original paper 1นะครับส่วนใหญ่ก็แค่ paper เดียวพอนะครับแต่ว่ามีมากกว่า1ก็ได้นะครับ
ก็ถ้าวันเดี๋ยวผมอยากเพิ่มทีหลังก็ได้
เติม S หน่อยแล้วกันนะครับคือเปเปอร์ที่คล้ายๆกันที่ทำ segmentation อะไรสักอย่างsegmentation ก็ได้ noise reduction ก็ได้นะครับอะไรก็ได้แหละที่ input เป็น image นะครับแล้วก็สิ่งที่เราสนใจก็คือบอกว่า what algorithm นะครับโอเคให้เขียน summary มาว่าเขาใช้ algorithm อะไรนะครับ summarize the algorithm they're usingนะครับแล้วเราก็มีการวางแผนนิดนึงว่า plan of action ว่าเราอะไรนะครับ summarize the algorithm they're using ก็คือมี introduction ก็ไม่มีอะไรเนาะก็คือ paper นี้กำลังจะทำอะไรอยู่เพื่อประโยชน์แห่งมวลมนุษยชาติอะไรอย่างนี้นะครับผมนะครับ objective ก็คือเรากะว่าทำแล้วเราได้อะไรขึ้นมานะครับ we suppose what you want to see at the end okay and then you summarize the algorithm they're using and then you say plan of actions okay maybe the flow chart okay what image you want to do okay and all those things where you can get the image from okay if they have the database you can use their database you specify the database they're using if they don't have the database you take the image yourself okay and then you apply it to yourself ส่งแค่2อย่างพอตอนนี้นะครับยังไม่ได้ส่งผลแต่ระหว่างนี้ให้ไปทำผลมาโอเคไหมครับส่ง2อย่างนี้ภายในอาทิตย์หน้าแล้วเดี๋ยวเราจะมาดูกันว่าทุกคนจะหัวข้อไม่เหมือนกันถ้าใครหัวข้อเหมือนกันเราจะต้องทำไมเราต้องเป่ายิงฉุกแล้วให้อีกคนนึงไปหาใหม่โอเคนะครับผมส่ง2อย่างนะครับส่งตัวเปเปอร์แล้วก็ส่ง summary ของเปเปอร์นะครับผมอบไอ้น้ำกำลังดีเลยเนี่ยวันนี้เหงื่อออกเยอะเลยไม่ต้องไปเดินออกกำลังกายเลย
ทำไม่ต้องเหมือนเปเปอร์มาก
ทำไม่โอเคไม่จำเป็นต้องทำเหมือนเปเปอร์โอกาสที่ยูจะทำเหมือนเปเปอร์เป๊ะๆคงไม่ได้แต่คุณจะต้องทำออกมาคล้ายๆเปเปอร์นะครับผมแค่นั้นจุดส่งหรืออาจจะ come up with a new idea ถ้า you come up with a new idea ที่ better than the paper you can publish the paper okay if you publish a paper you guarantee an A for this class okay if you come up with a new idea that looks better
เปลี่ยน
somehow
ฟิลเตอร์ใช้หลักเลยเปลี่ยน
โอเคนะครับทำอะไรก็ได้แต่ต้องมี objective ที่ชัดเจนก่อนนะครับแล้วก็มี plan of action ที่ชัดเจนเดี๋ยวเราจะมาดูกันนะครับถ้ายังไม่ชัดเจนเดี๋ยวผมจะบอกเองว่าไม่ชัดเจนยังไงนะครับต้องทำให้ชัดเจนนะครับแล้วเราก็ให้โอกาสทำเหลือเวลาทำกี่วีคในวีค1วีค1วีค2วีคประมาณ 4-5 วีคใช่ไหมจนถึงวันที่เท่าไหร่นะเรามาพรีเซนต์
สงกรานต์
สงกรานต์มีเวลา1 เดือนนะครับ1 เดือนทำให้เสร็จนะครับโอเคนะวันนี้เท่านี้ก่อนนะครับแอร์ไม่เวิร์กเดี๋ยวต้องรอให้คนมาซ่อมแอร์นะครับผมเราเหลืออีกแค่3 lecture morphology 2 lecture แล้วก็ description น่าจะจบทันนะหลังจากนั้นความจริงเราหยุดได้1 ครั้งใช่ไหมแล้วเดี๋ยวเราก็มาพรีเซนต์แล้วก็สอบถูกป่ะมันโดนวันหยุดแล้วโยนวันหยุดสงกรานต์ใช่ไหมเราจะโดนวันหยุดสงกรานต์ใช่ไหมโอเคครับผมวันนี้เท่านี้นะครับหาเปเปอร์ด้วย